Hey everyone, so today for my first video we'll be going over how to design an ideal op amp that reads as V out equals negative 5 V in. So what we need to first look at is V out will always be V in times a multiple. So we have to look first to see if this multiple is negative or not. And in this problem, it is obviously negative. It is negative 5 V in. So since we know that it's negative, we know that the op amp needs to be inverting, since if you have an input V in, if you put it into inverting op amp, it turns negative, and the result will be V out will be a negative multiple of V in. So to design an inverting op amp, the generic model of an ideal one would be the positive terminal will go straight to ground because we do not need any addition towards this number. We need a VN source coming from the inverting terminal with a resistor connected to it, and that will go to ground. We can name this voltage source V1 and this resistor R1 respectively. And we need V out, and we also need a resistor connecting the inverting terminal to V out. And this, we could also name this R2. This whole op amp is the generic model for inverting op amp, an ideal one. So from here, at the ideal op amp rules, number one, the currents going through the plus and minus terminals is always zero. This means the current going in here is zero, and the current going in here is zero. This means the current out is also zero. So therefore, the next rule is V plus, which means the voltage going into this terminal also equals the voltage in this terminal too. So V plus has to equal V minus. And since V plus goes straight to ground, ground is always zero. So the voltage in this terminal is zero. And since V plus, that terminal, is equal to V minus, this means that also this terminal is zero. And by voltage divider laws, voltage in parallel sections is always the same. So this voltage will be zero. This node voltage will be 0 volts. And what you need to know based on this is how to solve V out. So what we could do here is, since there's a junction right here, we could do KCL laws, where we could find the current coming into here, current coming out or coming in. And since this is 0, we don't have to worry about that for this specific op amp. So using KCL, we always determine currents that we don't know as going out of the node. So these two currents will be going out. So from here, to find the voltage in this little line, we would do 0, indicating this 0 voltage, minus V1, So we're finding the difference between the higher and lower voltage based on two different locations that are at the start of this line and at the end of this line. 0 minus V1 over R1. So you find the total resistance between these two voltages. So the total resistance will just be R1. And if you know Ohm's law is V equals I times R. And if you rearrange this to find current alone, we would do current equals voltage over resistance. And with KCL, this is basically what you are finding. We have a voltage over a resistance. So next, we have to find this current. So the voltage on this side will be 0 volts, and the voltage on this side of this will also be V out. So we add all of the currents. So 0, and since the current is going this way, as we assume, it may not possibly actually be that way. We would do 0 minus whatever voltage is on this side to find the difference. And that is just V out. We don't know what V out is. And we divide that by a resistance to find our current, which is R2. And since those are all the currents, this doesn't count because it's 0. Since those are all the currents coming out of the node, this will all equal to 0. That is the law. So here we have 0 minus V1 over R1 plus 0 minus V out over R2. Now, in our original problem, V out equals negative 5 V in. My apologies, this is supposed to be V in, not V1. Anyways, V out is by itself and V in is by a multiple of negative 5. So we have to make sure V out is by itself. So if we simplify this, it'll be, since 0 is 0, it won't mean anything. So negative V in over R1 minus V out over R2 equals 0. And we're just going to simplify and put this whole term on this side. So V out over R2 equals negative V in over R1. Now based on this, we have to multiply both sides by R2. So V out equals negative R2 over R1 V in. And this is the equation for an inverting op amp. Now, since we have the equation, we could relate it to this equation. So V out equals negative 5 V in. And with our equation, it is V out equals negative R2 over R1 V in. So based on this, these are the same and these are the same. So in essence, this must be the same as negative 5. So we could equal it to each other. Negative R2 over R1 equals negative 5. We could get rid of both negatives. R2 over R1 equals 5. Now at this point, we could make R2 and R1 whatever we want to equal 5. So we could just multiply both sides by R1. And this will be R2 equals 5R1. Now we can make R1 anything we want right now. So let's just say R1 equals 1 kilo ohm. Well, by this equality, R2 is just 5 times R1, which equals 5 times 1, which is just 5 kilo ohms. So In this, we learned how to design an ideal op-amp that reads V out equals -5 times V in. Now, we could redesign this to where we could put our values in. So, our voltage could be anything, so it'll always be V in. R1 is 1 kilo ohm. R2 is 5 kilo ohms. And V out will be a multiple of V in times R2 and R1.